Welcome back. Now, this video is going to help those of you with little to no knowledge of Java understand some of the core concepts before we begin coding the robot. If you already have a decent amount of knowledge on the language, you should probably skip this video. Okay, now to begin, we'll need to create our main opmode class. Opmodes are a list of instructions your robot will do when the play button is pressed. Under Java, right-click on org.firstinspires.ftc.teamcode, and under New, select Package. I'm going to go ahead and name it Opmodes. Now, packages are basically the Java equivalent of folders. They store all of your Java files, and they keep your project organized. Right-click on the newly created package, and under New, select Java Class. Now, a class is basically a file where Java code is stored. You'll have numerous classes by the time you're done with this, all in different packages in different places. Now, go ahead and name this class Test Drive. And also add it to Git. Okay. This file is where we will code the manual driving functions of the robot. But there are a few prerequisites we'll need to add to the class that I can help explain later. Go ahead and follow with me. At the top, type in @telyop. This is so it knows that we are going to be manually driving this. And between test drive and the squiggly brace, type out extends linear op mode. That way it knows that this is an op mode. Now, it's going to have a little red line underneath, but don't fret. That's completely normal. Go ahead and hover over it and hit Implement Methods. Then hit OK. A bunch of code will be put in the class that will help us begin. The structure by which we code Java is called its syntax. Java's overall syntax has many core parts. Variables, data types, if statements, loops, objects, methods, and much more. We're only going to cover some of the basics to get you started. Now, Java uses variables throughout its programming so we can hold on to data for later. So, let's say I wanted the variable x to be equal to 3, right? All I would have to do is type in x equals 3, right? Well, you may notice that I got an error. What's the problem? Well, Java doesn't know what you're trying to store. Are you storing a number? Are you trying to store a list? Text? Well, luckily, it's quite easy to tell it what we want. By adding int to the beginning, we are telling it that we want to store an integer. There are many types of variables. I'm just going to go over a few. Strings are a popular data type. Strings store text, not numbers. So let's see here. String s equals hello. Now you may notice that hello is red, and that's because when you're writing in text in Java, you can't just type it out. You'll need to surround it in quotations so it knows that you aren't actually trying to code. And now that you have quotes, it now recognizes it as a string. This can be used for many purposes. They can be used to send a warning message to your phone for errors or to receive other human-readable instructions. Another popular data type is called a double. Doubles are like integers in the way they store numbers, but doubles can also store decimals. These can be useful if you need to fine-tune how far your robot moves an arm or how fast it drives. So, for example, double y equals 0.2. Now, an integer wouldn't be able to store 0.2, but a double can. Lastly, Booleans are a way to store true or false. They're important if you want to check which direction a motor is turning, or if the robot is initialized or not. An example Boolean would be something like Boolean is on equals true. Now, Booleans can just be represented by true or false, but they can also be represented by conditions. So, say, for instance, x equals y. Now, does x equal y? No, 3 does not equal 0.2. So, is on would be equal to false. Now, these are just a few of the many data types you'll see, but there are many more, and I encourage you to experiment with Java and try and find some. Now, say for instance you want to make sure the wheels don't go too fast on the robot when it accelerates. You'll need something called an if statement. If statements are used to compare two variables. Say we have an integer called motor speed, which stores the current speed of the motor. For now, we'll set it to 10. Now, what if we don't want it to go that fast? What if we want it to be capped at 5? Well, we can write out if motor speed is greater than 5, and 2 squiggly braces, motor speed is equal to 5. What this is doing is comparing motor speed to 5 and seeing if motor speed is greater than 5. If so, it's running the code between these 2 squiggly braces. Now, let's say it's not above 5 and adhering to our maximum. If we wanted to add some code if it was below or equal to 5, we can add an else statement to it. After the squiggly brace, append else 2 squiggly braces system.out.println, and then inside of that, 2 quotes, congratulations, and then a semicolon at the end. This will send a message to the console saying congratulations when it doesn't meet the check in the if statement. These if statements are really powerful and can be used to create really cool things. Another fundamental tool are called loops. Loops run through code a set amount of times, so you don't have to copy-paste code over and over. There are 2 main kinds of loops, a for loop and a while loop. Let me go over a for loop with you. For, and in parentheses, int I equals 0. I is less than 5, and I plus plus. And then 2 squiggly braces. Inside of them, simply write system.out.println I. This for loop is made up of a few parts. One is the variable. This variable can be used throughout the loop body so it always knows which loop number it's on. The second part is the condition. Until the condition is no longer met, it will continue to loop. The third one is the action that will happen every time you loop. In this case, we're adding 1 to I, because I++ is the equivalent of I equals I plus 1. In essence, this loop is starting at 0 and counting up to 5. And every time it adds 1, it's spitting out the current number in the console, because I is the number of loops you've gone through so far, and we are printing it here. This can be useful for searching through lists, doing something a predetermined amount of times, and much more. Now, the second primary loop is called a while loop. While loops do a task while a condition is true. Here's an example. Let's say we have integer b and it's 0 currently. We can make a while loop that checks for b is less than 6. And then 2 squiggly braces. Inside of it, we'll put b++. This while loop is very similar to the for loop we just did. It has the variable, the condition, and it has the action that happens to the variable every loop. While it may seem like it's just the same, it's not. Let's say you have the variable is playing for the robot, which is set to true when the robot's play button is pressed, and set to false when the stop button is pressed. Now, of course, you don't want to run code before you press the play button, so even if the robot is on, you'll need to wait before moving the robot. An easy way to do that is this. First, we'll create a variable, Boolean is playing, and we'll set it to false. Now we'll need a while loop to wait until it's true. So we'll create a while loop, while is playing equals false. And now those double equals are comparing them. The single equals is setting a variable. And what we'll do is now is just have 2 empty squiggly braces. What this is doing is it's just going to keep on looping over and over again until is playing is true. Now, in this example, is playing will never be true, but on your robot, whenever you press that play button, it will be. And this will wait until you press the play button. As you can see, loops are very useful in many different applications throughout your robot. Let's backtrack a bit. What's this public void thing about? Well, this is called a method. Methods are bodies of code that can be called by other bits of code to carry out a task. In essence, Java is a bunch of methods calling other methods. Methods can have several properties attached to them. Some return variables after being called. some don't. This can be useful if you want to create a method to calculate 3D distance or to move the motors in a specific pattern. To do this, replace the void keyword with the data type you want to return. So in this case, we'll have move return a Boolean. And then at the end of the method, you'll want to have it return a variable. In this case, we'll just have it return true. So whenever you call move, it will, in essence, be like the Boolean true. So you could, up here, you could say that, hey, instead of Boolean is playing equals false, you can say is playing equals move. And it would work, because move will return a Boolean. In essence, you've created a method that acts like a data type. Now, you can also have an empty return statement for void methods. Now, void methods are basically methods that do not return anything. So let's say that you want to call a method, but you don't really need a number back, right? Or you don't really need a Boolean back. Well, you can set it as void, and you don't need to return anything. So in this case, it's erroring because you're returning something it doesn't need to return. So you can just delete true, and it will work. Now, return statements can be put anywhere in a method. In an if statement, so let's say if 5 equals 6, which it doesn't, but you can just say return. So if 5 equals 6, it would return. Otherwise, you can do something else. Return statements can be put anywhere in a method, and they are really powerful. Another property for methods and variables is visibility. Methods marked as public can be seen by all classes. However, methods marked as private can only be seen by methods inside of that class. Visibility can be useful to hide data from other classes if you want to add some sort of check method, usually called getter methods. It's good practice to hide variables from other classes unless you allow it to be accessed via a method, so you can more easily control how the variable is seen. Here's an example. Let's say you have the variable control stick X that reads how far you pushed the controller's joystick horizontally. It will be of type double. Double control stick X. And for now, we'll set it to 0. Now let's also say you have the variable break, which will be true if the break button is pressed. So public static Boolean break equals false. If a bunch of methods and separate classes want access to the control stick X variable to, say, calculate the speed the motor should move, you might be tempted to just pass along the variable. But if you do that, every single time you access control stick X, you would also have to check break. That's not very efficient. The easiest way to tackle this is to use a getter method. So for our example getter method, I would first set these to private, and then I would make the method public static double get control stick X. And then inside of squiggly braces, I would write if break equals true, I would want to return 0. Otherwise, I should return control stick X. Now what this is doing is it's saying, hey, if you're braking, then we should always return 0. Otherwise, return how far you're moving it on the joystick. This way, it's just way more efficient to code this way, and it's generally good practice. One of the last standalone properties we'll discuss are parameters and arguments. Parameters are variables you define inside of the parentheses that you want to be given when the method is called. For instance, let's say you want a method to set control stick X. While you could just directly set it, it's probably a good idea to have an intermediary method to factor in any other variables that could change it. Our method will be public static void set control stick X. Add 2 parentheses and 2 squiggly braces. In this method, we'll need to pass in the new variable we'll want to set control stick X to. How do we do that? See these parentheses here? These are where we store the parameters that can be used throughout the method. if we want to pass in the variable to define control stick X, you'll need to type out the data type and the variable name. The variable name can be whatever you want, but make sure the data type is the same as what you're setting. For this, since we're setting a double, we'll need to say double, and then we'll need our variable name, so new value, but you can set it to whatever you like. Now, we need to grab control stick X and set the new value. Since we aren't taking into account any variables like break, simply add control stick X is equal to new value, or whatever variable you set. There we go. The parameter is being used to redefine control stick X. Now, whenever you want to set control stick X, simply call the method and pass in the variable. So for instance, set control stick X, and then inside the parentheses puts a double of some kind. So 5.2 or 1.3 or 7. Anything will do as long as it's a double. The last core component of a method that leads us into this next part is the static bit. Static is a component of the fundamental concept called object-oriented programming. I'll give a brief overview of what it means. In essence, object-oriented programming is the idea that different classes can inherit each other and build on top of one another. A classic example is with cars. Let's say you have the class car with a color variable, a size variable, and a speed variable. Now, there are many different types of cars, each with unique features. Let's say you want to have a Tesla Model X class, which not only needs the color, size, and speed variables, but also a variable for how much charge is left, and a method that calculates the distance left on a charge. It would be pointless to add the components of the car class again, so we can instead have the Tesla Model X class inherit the car class using the extends keyword. Extends allows classes and objects to build on top of one another. Now, I've been using class and objects pretty loosely, but they do have differences. When calling a class, you only retrieve the static methods, but when calling an object, you get access to static and non-static methods. I'll break down what this means. To call a class, you would only put the class name in the method you want to retrieve, like this: car.drive. You also have to import the class as well. But to call an object, you instead get access to it through Tesla Model X, TMX, equals new Tesla Model X. And use the variable to call the method instead, tmx.calculateTotalCharge. In this case, objects can be useful if you have multiple different cars that have different properties and that need to be handled separately. So if Tesla Model X had a different rate of charge than another Tesla Model X, then calculateTotalCharge would return a different variable depending on which object you called it on. Now, before we go on to the next section, I'm going to highlight a notable class that will be useful for when you're coding your robot, the math class. The math class has tons of functions that are very useful. For instance, math.sqrt is square rooting the number you put inside of it. Math.abs is getting the absolute value of the number inside of it. Math.round rounds the number inside of it. And there's much, much more. Powers, you name it. You can access it anywhere, and it helps a ton when calculating distance and anything else. Thanks for watching this part. I hope you learned a lot. In the next part, we'll begin programming the robot.